Welcome everyone to today's webinar. We thank you for taking time out of your busy day to come and learn some new things with us, and we are extremely excited to have two of the most exciting teams, in my opinion, from the Cleantech Open 2018 cohort, and one of whom actually happened to be the national champions, so super excited about that, and the other, a national finalist, a Northeast finalist, and both of them represent a little bit of a departure from what was traditionally defined as clean tech, which is again what gives me a lot of joy to bring you their stories. And I wanted to start with a little backstory about Sustainable Minds for those of you who are not familiar, or even if you are, you probably wouldn't know this anyway, but I'm Terry Swack, the CEO and founder of Sustainable Minds, and Sustainable Minds has its origins in the Clean Tech Open, except that when I started the company in 2017, there was no Clean Tech Open. And in fact, Sustainable Minds is my second clean tech company. I started another one in 2015. Right around the same time, I was one of the founding members of a business plan competition that we organized here out of the MIT Enterprise Forum called the Ignite Clean Energy Business Plan Competition, where clean tech was just becoming a category, and people who were really interested in accelerating the importance of what clean tech could mean on the planet. We understood that starting a business plan competition was the way to accelerate innovation, and we banded together and did that. And a few years later, the Ignite Clean Energy competition became the Clean Tech Open. And so I have a soft spot in my heart for this competition for that reason. And the impetus for starting Sustainable Minds and the name of the company, Sustainable Minds, was we realized that we needed to get people to think differently, meaning sustainably, and taking a life cycle perspective on the design of products and systems. And then once they could think differently, they could act differently. So Sustainable Minds eco-concept and LCA software teaches people to think differently from a life cycle perspective and apply new kinds of strategies to each life cycle stage to improve the environmental performance, and then delivers life cycle assessment tools, easy to use and streamlined for non-LCA experts, so that people could think differently and act differently in the early stages of design of their products to drive environmental performance improvement. Last year, when we signed up to be in-kind sponsors, this is a function of the business plan component of the Clean Tech Open evolving over the last several years, adding a sustainability requirement to each business plan, where each of the teams not only needed to talk about the contribution to clean tech, clean energy that their company was going to make, but to also be able to tell the sustainability story about their products or their systems or their solutions having less impact on the environment while creating new opportunities for energy and innovation. And so providing subscriptions to our eco-concept and LCA software to any of the teams that wanted to use it to help evaluate their products and tell their stories. We also delivered some training and support, and you're going to see how Radical Plastics has used Sustainable Minds software not only to tell their story, but to continue evaluating some of the solutions, the way they're bringing their products to market. I like to share this slide because I was pretty excited when they put the Sustainable Minds logo onto the Clean Tech Open website, and notice we are a national in-kind sponsor right alongside the other national sponsor. You know, don't blink, you'll never see Sustainable Minds again alongside a national sponsor of that caliber, but we're pretty excited about that. So that's our backstory, and I'm going to flip over here to the presentation. And really, without further ado, we're going to go right into Radical Plastics story, followed by Techstyle materials. Now, I'm sure you're going to have a lot of questions, and this really is a session about introducing two really innovative concepts that both impact in terms of plastics. Everybody cares about that. It not only is applicable to the building products industry, which is our focus right now, but to every industry. And Techstyle materials is specifically looking at the trend in building products of multi-purpose products. And I think it's going to be an important insight for those of you who are in this industry to see as the industry evolves, as we try to reduce the impact of the built environment on the natural environment. And what I want to wrap up with, and what I particularly like about these two companies, is clean tech, when the term was coined, was fairly narrowly defining clean energy technologies that were expressly about renewable energy or energy generation. And over time, the definition of clean tech has expanded to include technologies that are addressing reducing impacts of materials, energy, processes, human behavior, and has become a much more broadly defined term. And I think that's pretty important because it is an important investment sector to accelerate the kinds of innovations that we need on this planet. So without further ado, Kristen, I'm going to ask you to take it away and tell the Radical Plastics story. And questions, type them into the questions panel. We're going to take them all at the end.
Great. Thank you very much, Terry. As Terry said, I'm Kristen Taylor, CEO and co-founder of Radical Plastics. Radical Plastics is a Boston-based startup, and as Terry mentioned, the 2018 national winner of the Clean Tech Open Accelerator program. And we're focused on commercializing a radical solution to plastic pollution. So what is the challenge? Well, the challenge is that plastics are pretty amazing. I would argue that they're one of the most important inventions of the last century. They're strong, lightweight, cost-effective, versatile materials that have really transformed our daily lives. And that's why it's a $650 billion industry. But plastics have a problem. They don't go away. In fact, it's estimated that around 80% of all plastics that have ever been produced are still here somewhere. We make around 380 million tons of plastic annually, and around a quarter of that is packaging, which usually has a lifespan of less than a year. At this rate, there'll be 12 billion tons of plastic in our landfills by mid-century. And to give you an idea of what 12 billion tons looks like, that is 35,000 times the weight of the Empire State Building. Historically, around 9% of plastics has been recycled, but since China shut its doors to our incoming recycling in January of 2018 through the National Sword Program, that number's been cut in half to around 4.5%. And as much as we try to do the right thing and put containers in the right bins, all of our collection systems will remain imperfect and leaky. And as a result, over 8 million tons of plastic ends up in our oceans each year. And that is the equivalent of 5 grocery bags of plastic trash for every single foot of coastline around the globe. This is a complex problem, and it requires a variety of solutions working together to solve it. At Radical Plastics, we want to be part of that solution. We've developed a technology that uses a non-toxic, naturally occurring waste product from the mining industry called fine mineral matter to create a unique free radical catalyst. When properly compounded, this catalyst has the ability to render conventional plastics biodegradable in the natural environment. I want to be clear that this material that we're selling are plastic pellets. We're not selling the additive, the catalyst technology. We're selling fully formulated plastic pellets. And the reason for that is that we want to control all of the ingredients in those pellets so we can control the onset of degradation and the rate of degradation, anywhere from 4 months to 2 years. by controlling all of the ingredients. We want to closely control the performance of that drop-in resin. We filed for a provisional patent on this technology last March and converted the patent about a month ago, March of 2019, in addition to our PCT filing on the technology. If this material should happen to end up in the environment, it would undergo a two-stage degradation process. The first is a chemical stage, where this catalyst system breaks down the long polymer chains into smaller oligomers and also inserts polar groups along the chain. This makes the polymer hydrophilic or wettable so that a biofilm can form on the surface, which is the first step of biodegradation. And what's really key here is our self-regenerating catalyst drives this reaction, this degradation reaction, to completion, so that the polymer, which starts out around 100,000 grams per mole in molecular weight, is reduced to less than 20,000 grams per mole in molecular weight. At that point, it becomes bioavailable to microbes that live in the environment. And this is key. We're not just fragmenting the material. We're not breaking it down into smaller pieces. We're actually changing the chemical composition so that it becomes biodegradable. So this chemical phase then triggers a second biological phase, where microbes in the environment, whether they're in soil or oceans or fresh water, see this material as a food source, and they metabolize it into biomass, CO2, and water. And also there is a trace amount of mineral that is left in the soil, and this fine mineral matter is actually used currently as a soil conditioner. Farmers blend it into their soils to make the soil healthier. So this trace amount of mineral is only healthy for the soil. There are no toxic heavy metals or toxic materials, and it meets EPA 503 standards. So our initial target market is one that really takes advantage of the soil degradability of this material, agricultural mulch film. Farmers spend around $4 billion a year on mulch film. Most of it is low-density polyethylene or linear low, and they use this material to prevent weeds, but also to decrease their water and fertilizer usage and to increase their crop yields by as much as 60%. But because of most of this film is non-biodegradable, at the end of the growing season, the farmer has to pay to have all of this film collected, transported, and disposed of. In fact, it costs an average of $180 an acre to buy the film, and an average of $250 an acre to get rid of it. If they used mulch film that was made from the Radical Plastics biodegradable compound, they could just till it back into the soil where it would biodegrade before the next growing season. So while we're talking about mulch film, let me show you the general supply chain for this product. It starts with a basic resin, a barefoot resin made by a resin manufacturer like an ExxonMobil or a Dow. They sell this resin to a compounder, and frequently the compounding operation also occurs within the resin manufacturing operation. So this raw resin is compounded with additives, with processing aids, with colorants, and then these resin pellets are sold to a film extruder. They make the mulch film, which they sell through distribution to the farming community. Now again, it's our intent to produce the fully formulated compound, not just the catalyst. We're selling this fully formulated compound, again, to control the degradation performance of the material, but also because it is a capital light entry point into the market. There's a lot of capacity out there for low-density polyethylene compounding, and we're taking advantage of that. We're not building a whole plant, a materials processing plant, which can be very expensive. We're dropping into the current supply chain by providing that compound. So in terms of the competitive landscape in mulch film, the inherent material right now is low-density polyethylene, as I mentioned. It's a great material, low cost. It has excellent physical properties, good tensile strength, barrier properties, and it's really easy for the farmers to use. They attach these rolls to their tractors, and it's very easy to apply to the fields. But as I mentioned, it's very expensive to remove, transport, and dispose of, and that disposal method is generally incineration, which gives out a lot of greenhouse gases. So there are other biodegradable mulch films that are on the market. They're usually either based on starch or starch polyester blends. The starch-based films are biodegradable, but the polyester materials are compostable, so they would still need to be collected and brought to an industrial composting facility. And the problem with most of these materials is that they don't have very good physical properties. They don't look and feel and act like regular plastic. They're more fragile, they're more humidity sensitive, and they're difficult to apply to the fields. In addition, they're usually a lot more expensive. But farmers are buying this material because they know they'll save money at the back end of the season. But they do have a lot of problems in terms of physical properties. So we address this problem by incorporating our free radical catalyst into conventional plastic. And in this way, we have a low cost of production, very similar to the low-density polyethylene, and we retain the excellent properties that farmers are used to, the high tensile strength, the barrier properties, and they can lay this down with their conventional equipment. So we're really acting as a drop-in replacement for low-density polyethylene. And of course, at the end of the growing season, we have the advantage of biodegradability. So farmers are saving time and money by not having to collect and dispose of film at the end of the season. What this allows us to do is expand the margins rather, in this $4 billion market. On the left, we have low-density polyethylene films, which are pretty low cost to manufacture. They sell at pretty low margins, but there's a huge cost to the farmer at the end of the growing season for removal, transport, and disposal. So that costs around $400 to $500 an acre total. Starch-based films are a lot more expensive to make, partly because of scale, and they also have relatively thin margins. But farmers, again, are buying them because of the advantages that they have at the end of the season. The radical plastics films will have that low cost of manufacture because they're produced with the same equipment using a conventional polyethylene resins. But this allows us to really increase the margins across the supply chain because, again, we're charging that $400 to $500 an acre range. In addition, there are lots of life cycle advantages, which Yelena Khan will speak to.
Hello, I'm Yelena Khan, founder and CTO of Radical Plastics. Life cycle assessment provides comprehensive and quantitative analysis of the environmental impact of a product throughout its entire life cycle. LCA is a powerful and widely used tool for making informed decisions with respect to sustainability and environmental considerations. The system boundaries of an LCA may extend from cradle to gate, cradle to grave, or cradle to cradle. Cradle to cradle indicates that the product can be returned back to the natural environment and biologically recycled for uptake by biomass. LCA can be comparative or standalone. We have conducted a comparative analysis and included the just discussed mulch film products, PLA starch blends, which is a compostable version, a non-biodegradable LDPE films, and radical plastic soil biodegradable LDPE films. The goal is to determine the environmentally preferable alternative. LCA data is readily accessible in the Sustainable Minds software for most petroleum-based polymers, as well as some bio-based polymers. We have chosen to report results for the production of 1 kilo of a product, either pellet or a film, which is used for 1 year. We show on this slide that greenhouse gas emissions and CO2 equivalent for the discussed films considered within cradle to grave boundaries for non-biodegradable LDP and cradle to cradle for biodegradable. And it can be concluded that Radical Plastics petroleum-based film produces 50% less greenhouse emissions compared with non-biodegradable LDP. This is for the virgin resin. And the impact can be further reduced if we use post-industrial recycled LDP. Looking at different stages, specifically cradle to pellet, pellet to film, and film to grave, end of life, we see that majority of the greenhouse gases are produced by incineration of non-biodegradable LDPE. We also see little difference between the bio-based and petroleum-based polymers in their early life in regards to the greenhouse gases produced. The other reported environmental categories are presented on this slide. You can see that there are environmental trade-offs. Eutrophication, ecotoxicity, and carcinogenic human health exhibit higher impact in bioplastics versus petroleum-based plastic films. Of course, bioplastics exhibit lower fossil fuel depletion, but they're definitely not carbon neutral. To summarize, our analysis has demonstrated that Radical Plastics soil biodegradable films have better overall LCA and win in the categories of greenhouse gas emissions, lower global warming potential, lower human health, ecotoxicity, and eutrophication impacts. Thank you. Back to Kristen.
Great. Excellent. So our business plan for this technology, we are raising our seed round right now so that we can do a large-scale technology validation. We've produced this material at pilot scale, and we've made a couple hundred meters of film, which has allowed us to do some pilot scale testing that show that the material is in fact biodegradable, that it runs very similar to low-density polyethylene. But this funding will allow us to do a larger scale validation and collect more data so that we can submit for our biodegradability certifications by the end of the year. This will allow us to launch in agriculture in 2020. And then in 2021, we expect to be licensing the technology in some parallel markets. There are a lot of applications for which this technology would work, for paper coatings, for example, but also to launch in flexible packaging. Flexible packaging is a $150 billion industry with a very urgent and a very visible problem right now. Plastic pollution is really top of mind for consumers, for manufacturers, for NGOs, and certainly it is for brand owners. And we are offering a drop-in replacement solution for conventional plastic that has a fail-safe built into it. You know, Terry talked about building our products from the beginning with the end of life in mind. And that's what we can do with this Radical Plastics technology, is design packaging materials so that they have an expiration date, a useful life where they perform like they're supposed to, but then a fail-safe built in at the end of that useful life so that if they're leaked into the environment, they do not last for hundreds of years. So Yelena and I are really excited about this technology because we are veterans of the plastics industry. And we also have a really good team of advisors, including our former CEO of Metabolics, Rick Eno. Yelena and I worked together at Metabolics Bioplastics for over 6 years. And in addition to that, we have a strong team of experts from agriculture, from biopolymers, from industry, from government, from academia, who have looked at this technology and are really eager and excited to help us get it to market. So we are really focused on agriculture initially, but then flexible packaging soon after, and we really feel that the time is right. This Alliance to End Plastic Waste was launched on January 16th of this year, and it includes over 30 companies from across the supply chain who are looking at this problem from all different angles to try to find solutions to the plastic waste problem. So we are very, very timely in this solution. And while we're focused initially on the agricultural market, we see huge opportunities for flexible packaging and beyond. So thank you so much for your attention today. We hope you'll support Radical Plastics and its game-changing solution to plastic pollution. Thanks.
Thank you, Kristen and Yelena. I get reinvigorated, even more excited every time I hear your presentation. And of course, Sustainable Minds is committed to doing everything we can to see you achieve your desired outcomes. We're going to move right ahead onto textile materials, another super exciting story. And Derek, I'm going to ask you to tell it.
Okay, thank you. So first I want to thank Terry for putting together this webinar and for inviting me to participate. My name is Derek Stein, and I'm the founder and CEO of Techstyle Materials. I'm also a professor of physics at Brown University. And I founded Techstyle Materials to make the built environment energy and sustainable by developing innovative smart building materials. So here is the problem we're trying to solve. Everybody wants the same features from buildings. We want several characteristics. We want energy efficiency. We want buildings to be comfortable. We want them to be durable, and we want them to be cheap. The problem is that these user demands are all in tension with one another. To illustrate, I'm going to show here on the right an image of a standard residential wall assembly that's been cut out so you can see the various layers. We know how to make a building energy efficient. We can add lots of insulation in between the studs, and then we can make it very airtight by adding paneling. The problem is the same process of making it energy efficient also tends to trap in moisture, and that can lead to mold, mildew, rot, and other moisture-related problems. So paradoxically, the process of making a building energy efficient can in fact make it less durable, less comfortable, and less healthy. There are solutions to that. We have to add more layers to the building structure to control the motion of water in its liquid and vapor forms. And in doing so, what we end up doing is making the building structure more complex. So while we've solved these problems, we've resulted in something that's more expensive to build. So in sum, there are products on the market that can satisfy any one of these consumer demands, be it efficiency, comfort, durability, and affordability. But customers can't get them all at once, so they're forced to pick and choose. Techstyle Materials is developing a solution based on a new materials science technology. A millimeter-thin coating of material can be applied to standard construction materials, like drywall, sheathing, and roofing, to transform them into what we call smart materials. A smart construction material is one that responds automatically to its environment and can passively manage the flows of heat and water. By taking the place of multiple layers in the building assembly, we can simplify construction and make buildings more affordable. And finally, the process of adding these materials onto standard building products is something that drops into processes that are existent in the building industry. And as a startup company, moving this material technology from a lab into the marketplace, we're eager to work with partners to find the best ways of quickly dropping in this new material technology into their existing manufacturing processes. So here are the different functions of this multifunctional material. Fundamentally, this material does three different things. First, when the temperature rises, the material absorbs heat. And when the temperature of the environment falls, it releases heat. This action controls the temperature and saves energy that would otherwise be used by the heating, ventilating, the HVAC system of a building. The material also absorbs water vapor when it gets humid, and when it gets dry, it releases water vapor into the environment. This controls the relative humidity, maintaining comfortable conditions and a greater durability. And then the last function of this material is perhaps the most exotic. This material knows direction. It will let water vapor leave a wall assembly, but won't let it back in again. It acts as a one-way valve. And in so doing, it in fact actively removes moisture and water vapor from inside the wall cavity, where it poses risks like mold, mildew, and other damage. The core IP for this technology is contained in a pair of patent applications that are owned by Brown University and to which Techstyle Materials will have exclusive licensing rights. We're also beginning to build up an IP portfolio based upon new functions, new material formulations, manufacturing methods, and then design aspects. Techstyle Materials is a technology company, and we're seeking to innovate in building materials. Now, this is the right material and the right time for it. These multifunctional properties that I described, they're not magic. They're based upon well-established thermodynamics of materials and how certain materials interact with water vapor and absorb and release them. The materials that we're using are abundant and they are inexpensive. And the secret to them is that they contain a huge amount of surface area on the inside. So for example, a teaspoon of such material can absorb and release from an area, a surface area equivalent to a football field. Furthermore, it's possible to tune these multiple functions for optimal performance in different environments. We know that you need something different in Southern California than you do in Louisiana because of the different humidity. And here in the Northeast, we need mixed functions to control humidity going in and out in summer and winter. And these properties can be tuned with our technology. Now, to bring this product to market, we need to provide a compelling value proposition to three different groups of actors. And that's because the construction industry is fragmented and notoriously complex. So first, to end users, we offer better performance. A building that's 3 to 6% more energy efficient, which will lower bills for heating, ventilating, and air conditioning. Second, this is a building that's more comfortable because this can stabilize humidity with great effect. For example, a millimeter thick coating of this material in the walls of a house can absorb and release more than 30 liters of water, easily able to handle the drivers that happen inside the house. Finally, this is a building material that will reduce the risk of mold, rot, and other related problems, adding to the durability for the end user. To the builders, we offer savings on labor. Now take, for example, drywall. Here in the Northeast, code requires that exterior walls have a vapor retarder behind a layer of drywall. The materials cost a total of 61 cents per square foot. And the cost of installing these two separate layers amounts to about $1.75 per square foot. In other words, building the thing costs much more than the materials that go into it. The labor is dominant. What we plan to do is introduce a smart drywall that will integrate these different functions. The materials will cost 96 cents a square foot, and the builders will be able to save 40% on labor. And as long as they do, the builder will come out ahead at $2.01 a square foot total as compared to $2.36. Now, finally, materials for construction are typically supplied by huge companies that work on large volumes and small margins. What we offer to them are opportunities to increase their profit margins through licensing, and in a way that will capture some of the savings from the costs of construction, the labor costs of construction. These are materials that address known moisture problems in the construction industry. Nobody builds a building intending for moisture to get inside, but inevitably manufacturing defects, building defects lead to it, and this adds to that stability. And then finally, with our products, we offer these manufacturers a way to lead in the development of advanced building technologies. I've worked in the past with Saint-Gobain on a project called the Solar Decathlon. I've also been a participant in the Building Materials Challenge sponsored by Stowe, a manufacturer of wall systems. And there are a number of other potential partners that Techstyle Materials could work with to integrate its technology into their building products. Now, to illustrate why multifunctionality has a place in the market, I want to turn to a different market than drywall. I want to turn to sheathing, because what's happened in the last decade is extremely illustrative. Just over 10 years ago, the sheathing of a building would typically be made of oriented strand board, and then that would be covered by building wrap, something like Tyvek. The total cost of those materials at retail is about 59 cents a square foot. Then about 10 years ago, a new product came on the market called Zip System. Zip System is essentially oriented strand board with a laminated weather barrier on top, and it currently retails for about 91 cents a square foot. Now, despite the clearly higher material cost of this product, Zip System has managed to capture about 11% of the US sheathing market. Despite its high material cost, the market loves it because the market values construction efficiency. Now, a Techstyle Materials smart sheathing product would offer similar construction efficiencies, but just greater performance in terms of efficiency and durability. The way we intend to enter the market is through a beachhead product, which is smart drywall, for which currently the standard way of building is with 2 layers rather than 1. And we want to target LEED certified commercial and university buildings. Universities and companies have made sustainability commitments in recent years, and they typically employ sustainability officers who are willing to scrutinize building plans and make sure that these things can pay off over the course of years. So if something does pay off in 5 years, they're willing to make that initial investment. And this small market alone, in the US alone, amounts to $300 million. It's obvious that this can be followed on with marketing to all commercial and residential buildings, which increases the market size to $2 billion in the US, and then following up with diversified products. So smart sheathing products, roofing products, and then other sectors where the management of heat and water is important, like agriculture, for greenhouses, for example. Now, we are taking a product from a university research lab, my laboratory at Brown University, and we want to turn it into a commercial product within 3 years. And we plan to do this in 2 phases. The first phase, which will begin in a month, is aimed at developing a prototype. To take something that's made by hand in a petri dish in a lab, we want to show that this can be manufactured at scale. We want to validate some of our assumptions about the cost of adding this material, which we estimate can be done in a factory setting at a cost of only about 15 cents per square foot. And we want to be able to make prototype materials that can be deployed for field tests to show that the technology works under realistic conditions. In the second phase, we'll go from a prototype to a product. We estimate that this will take about 1.5 years, and this will involve the necessary safety testings and things that will ensure that we can safely introduce this into the market. Along the way, we have company building to do. We are going to be developing our IP portfolio, recruiting a full-time CEO to take over for me as I move into a technical officer role. And then we want to develop our strategic partnerships to introduce this into a variety of products. We're at the early stages of developing this company, and so right now we're considering 2 different business models. One is a low capital business model that's based mainly around royalties. So within this model, we intend to seed the market with products that are developed and produced through toll manufacturing. And this is to show that there's an appetite for them. The real goal, however, is to license these things and for the main revenue stream to come in through royalties and consulting contracts with our industrial partners. A second business model is based upon developing and manufacturing smart building products ourselves. Now, this is something that will be a more capital-intensive enterprise, and one for which a successful route forward will depend on developing the right partnerships. So if, for example, we can partner and become, for example, the subsidiary of a company with enough market reach, this is something that offers an opportunity to be truly disruptive. Now, the team includes me. I am taking leave from my professorial duties at Brown so I can push this full time. Ben Wiener is a PhD in physics who's graduated from Brown University this year and is anxious to become the first employee of Techstyle Materials to push the development of a prototype. And the advisory team includes people with business development expertise running startups, licensing, and architecture. So in summary, Techstyle Materials is offering innovative products for a multi-billion-dollar US market. There's a clear need for multifunctional construction materials in the building market, things that will move from field to factory in the construction business. And our proprietary technology offers a unique way of increasing performance and collecting some of those construction efficiencies. And so at this point, we're welcoming discussions with industrial partners and early stage investors to help us make this a reality. Thanks for your attention.
Derek, thank you so much. And again, every time I hear your story, I just get so excited. I mean, this story hits on every green building cylinder. Once you get a product into production, and particularly that your early target is LEED certified buildings, you'll get the transparency disclosures, you'll do an EPD, you'll get the material ingredient disclosures, and building professionals will spec this product all day long, and it will never get substituted by the contractor, because they're going to make way more money installing this product over any other product. It's just brilliant. So Derek, you guys are going to hit it out of the ballpark. And we're going to go now to, we've got a good chunk of time for Q&A, and we've got some good questions that have come in. And again, if you've had some questions that you haven't asked yet, please go ahead and answer them. Or please go ahead and submit them. And we're going to start with some questions directed to Radical Plastics and Yelena and Kristen, whichever one of you wants to answer. Go ahead. First question is, have you run tests with BPI, Biodegradable Plastics Institute?
We did not run tests with BPI yet. BPI usually certifies compostable samples, so they have STM D6400 as their working test. So we are aiming at ambient soil and marine biodegradability.
And following up on that, have you run any pilot trials with farmers?
We have not yet. We are starting this year.
Perfect. Now the next question is, what happens to Radical Plastics materials in landfill, but why would it end up in a landfill? Would be my add-on to that question.
Well, yeah, do you want to take a
Sure. You know, it could end up in a landfill, and in a properly run landfill, most things are entombed. There's very little oxygen, very little degradation, and it would just be an inert material like conventional polyethylene. Ideally, if it saw some UV and some moisture, it could start to degrade and reduce landfill volume, which certainly is needed. But it wouldn't act as a contaminant in the landfill. Ideally, it would be able to biodegrade to some degree.
And can the Radical Plastics catalyst work with plastics other than PE?
It can work with plastics other than polyethylene. Basically, any plastics that are made through addition polymerization. So not only polyolefins, but styrenics, vinyls, not the condensation polymers in particular, but just any plastic that's made through addition polymerization, yes.
Yeah, if it has bonds which are sensitive to oxidation, yes. If it has bonds which are sensitive to hydrolysis, no.
Okay, let's throw some questions over to Derek. So, Derek, it sounds like your material behaves a lot like Gore-Tex. Can you explain the similarities and differences?
Yeah. So Gore-Tex is famous because it is water repellent. So water will drip off it, but it's breathable. And so that is extremely useful for clothing and so on. And in fact, those properties are very similar to the building wraps that one would normally put on the outside of the sheathing. The difference between what we've developed and Gore-Tex or Tyvek is that the breathability goes one way. And so whereas water getting on and the inside of a wall cavity can get out and breathe, it can't get back in again. And so this one-way valve capability is kind of like, you know, for people who are into electronics, it's like a diode. But what it does in the end, it allows a building envelope to actually pump water vapor out of a wall cavity. It allows the wall to harness energy from the environment and move water in a desired direction.
Cool. You're going to have to come up with some snappy brand name, Derek. That after you get your second round of funding, you'll have a budget for branding, right?
Right.
Well, given that we're throwing some questions your way and we've been talking about end of life, here's one that combines both topics. How might the textile product work at the end of life? Does it prohibit or facilitate recycling of wall products at end of life?
So we are at an early stage of development, and that is a good question and one that's at the top of mind. And so we're early enough in the design process that we can take that into consideration as we work to integrate this into different products. My desire is for this to become part of a circular economy of materials. And so the material is based upon two components, two subcomponents, one of which is an abundant and inexpensive material, mineral, that's common in the environment, and it's actually used in a variety of applications. I can imagine recycling being done on that. And then the second component is a polymer, and it is a polymer that could be obtained from recycled sources. There's the potential of recycling it. That polymer is not specified yet to the point where we say it must be this, like it must be PET. There's enough flexibility in what it actually is for us to bake recyclability into the design process. And that's something that we look forward to doing as we go through our prototype development process.
Yeah, Derek, circular economy is such a hot topic right now. And so thanks for using that term. And given that you are already hitting on all cylinders with your environmental performance and sustainability story, being able to certainly hit on a material health story and a circular economy story is really going to get you an unassailable position in the market. So I'm going to throw a practical question over to you, and this is going to be important to any of the strategics that you're looking to partner with, and certainly those who don't partner with you or don't become one of your customers in a business model is to license the technology and consult. What's going to happen to the way people specify products? Will building owners and designers who want more efficient buildings, will they be choosing between more insulation and or using your multifunctional material?
Yeah, good question. The reason why this multifunctional material was developed, the inspiration for it, was a recognition through this solar decathlon project that I participated in, that greater insulating buildings face increasing problems of durability. The more insulation you put in something, the more at risk the building is of succumbing to rot and mold and other problems. And I have since learned that this is a big economic concern for developers, builders, and material manufacturers, because recalls and lawsuits and things ensue when mold damage happens well before the specified time, the lifespan expires. So fundamentally, this material is a solution to that recognized industry problem. I see this going hand in hand with insulation, and the more that users want to specify high energy efficiency, the more they will be looking to textile materials to give resiliency to these wall assemblies that are necessarily high R wall assemblies.
Yeah, and not to mention the simplification of the specification of a wall assembly, which is one of the most complicated things in building design today, is specifying all those pieces that go into the assembly. So that's a great, yeah, that is a great.
That's an excellent point. The building needs to work as a system,
Yep.
and thinking of it as just a collection of interchangeable parts where we don't have to scrutinize the performance of each one too carefully puts one at risk of getting a nasty surprise. So increasingly, people are starting to build an understanding of how various components work as systems, and it only makes sense to start specifying buildings in terms of these systems of components. And when a system has been demonstrated to work well in terms of performance, cost, resilience, then it makes sense to keep specifying that system rather than just individual parts.
Absolutely, absolutely. We've got some more questions to throw back to Radical Plastics, and I think this is probably one that would be on anybody's mind, which is, does the plastic leave a residue? Is the breakdown product safe for drinking water?
Excellent question.
The plastic is fully biodegradable and leaves no residue other than the biomass it creates when the product of the degradation is left as a soil amendment. Yeah. So
again, and the mineral that we're using, the mineral powder that we're using, is a soil amendment currently, so it's been tested as safe per EPA 503 standards.
And I think that there was an earlier question about what happens should it end up in a landfill. And again, just a top of mind question, will it biodegrade in the absence of light and water? It needs to be exposed to the open environment first to activate its catalytic nature. Once it's activated, because we do have an inhibitor which provides some service life, so when the inhibitor is consumed, then the degradation starts, and it could be continued in environments which are not containing oxygen or UV.
Right, so once the catalyst begins to work, it continues through completion, even if it's not exposed any longer.
I don't think you touched on the fact that you are able to program when the biodegradation process begins. And I think that is one of the most exciting features of this. Can you talk a little bit about that, Elena?
Right. I think Kristen has mentioned that right now we have demonstrated that we control the onset of degradation somewhere from a couple of months to a couple of years, well, 2 months to years. We have not explored outside of this time frame, so probably it could be expanded to. Yes, so because we do this complete formulation, so it's the art of putting together the right resins with the right additives and make sure that everything starts working when it's expected to start working. So based on the applications, we will design the formulation of the compound to last for a certain time. And then when it's no longer needed, it can start breaking itself down.
So the use case for that in the agricultural film space, do you want to tell that story? Because I think that really brings this capability to light.
Sure. In the case of agricultural mulch film, you'd probably want the film to last anywhere between 4 and 6 months. So we can design in the catalyst and co-catalyst and inhibitors into the resin pellets so that they have that service life and they are functional for that 4 to 6 months. But then that catalyst kicks in and starts to degrade the film. So when you till it into the soil, it still biodegrades even though it's under the soil. For a packaging film, you might want it to last for closer to 1 year to 2 years before that degradation process starts. And I should mention, you talk about the circular economy. Recycling is an excellent end-of-life scenario for this material. This material, because it's made from conventional plastics, can be recycled along with conventional plastics, which was a huge hurdle for a lot of the bioplastics that are out there that actually act as a contaminant to the recycling stream. We want to support the recycling stream, and any products made from this technology can be recycled along with conventional plastic, which is a really key point.
Right. We have another question. Clarification, what is the difference between the Radical Plastics catalysts and OXO additives?
Sure. OXO additives, for those who might not know, it's an additive technology that people would buy the additive off the shelf and blend it themselves into a resin system. 2 major differences. First of all, we are not an additive. We're providing a fully formulated pellet. And what that allows us to do is control the performance of the material. So again, OXOs you could buy off the shelf and add to a resin system that has inhibitors and antioxidants that would counteract the performance, and then it would not biodegrade. This causes microplastics in the environment. So the OXO degradable materials would start to degrade the polymer, but depending on the makeup of that formulation, that reaction would stall, and then the material would just fragment into smaller pieces. We're a true catalyst, and our catalyst regenerates So once that starts to activate, it continues until that molecular weight is below that key 20,000 grams per mole.
Just to connect the dots, going back to the agricultural film story, and again in this life cycle of the farmer, and Kristen showed some of the costs that farmers pay today when they buy agricultural film. It has to get transported to the field. It's very expensive. Then it's the growing season, and the growing season's over, and then they have to pay to haul that away, which is even more expensive than the cost to bring it in the first place. In this scenario, the Radical Plastics agricultural film goes down, the growing season's over, it has been programmed now to start to biodegrade at the end of the growing season, and by the time the next growing season comes around, not only has the farmer not have had to haul it away, it simply gets plowed into the field as an organic compound, as a fertilizer, and the growing season starts over again.
Right, exactly. And it was designed to continue to biodegrade after it's tilled into the soil. And tilling is something that they would normally do at the end of the growing season to get rid of leaves and stems. So this material will biodegrade along with the other organic materials.
Right.
Yeah, and it's true because it does contain those metals which are known to be micronutrients. They're returning those metals to the soil, and that's why there is a lot of data which shows that the quality of soil and the health of the plants subsequently grown in the soils are improved.
And my understanding is that you have a handful of farmers who have lined up
Yes.
to say, test it in our field. Our field.
We have over a dozen farmers who are waiting to receive film. So we're ramping up. We're doing compounding and film extrusion trials in the next few weeks so that we can get the film in the fields to do some real-life studies. We're also working with several universities around the country who have more controlled studies in place that we're taking part in.
Right. All right. Well, this has been great. I learn something every time I hear both of the stories from these companies and think of more ways to try to get the right people to hear these stories. And if you attendees have questions that you would like to pass on, you can send that to us, or you might have got their email addresses in the slides. The deck will be available because this is non-confidential information. The recording will also be available, so you'll get links to both in the follow-up email from the webinar. And if you have strategic partners or yourself do angel investing, both companies are in conversations now and looking at the longer-term investment horizon. So I want to thank you for taking your time out of your busy day to learn about some exciting new technologies, and pay attention to the Clean Tech Open. If you're familiar with any entrepreneurs who are looking to do clean tech startups, point them to the Clean Tech Open. There are regional chapters. It's a phenomenal accelerator, taking entrepreneurs with great ideas and really helping them turn it into a business and a company that can be funded and get their ideas out into the world. So thanks again, and have a great day.